you can take a square root and you can divide it into its different factors. So we know that 4 times 25 equals 100. So it's okay for us to break it in to separate factors like this, as long as we keep the radical sign above each of these factors. And I can show you down here that they do equal the same thing. Since we know that this is 10, well, this is 5 and this is 2, and this would equal 10, 5 times 2. And this is just, you're looking at two equal factors multiplied by each other. So 5 times 5 equals 25, and then 2 times 2 would equal 4. So that's how I came out with each of these numbers. And it equaled 10. So we proved that this is right. And in this case, it's not super helpful because this is what we call a perfect square root. This means that it simplifies to a whole number, just like this. Very beautiful. You know, it has no other remnants of a radical sign, but sometimes you come across something that is not as easily turned into a square root, like this. Taking the square root of 50 is actually difficult because there is no whole number times by itself or multiplied by itself that will equal 50. So what we have to do is we have to break it into its different factors until we can find something to simplify down. So we know that 25 times 2 equals 50. So let's break it up into those two factors. So 25 and then 2. And we know this just from this top equation. We remember that the square root of 25 is 5. And can we break this down to anything? Are there two equal factors that when multiplied against each other will equal 2? There's no whole number like that. So what we do is if it's not a perfect square, we leave it there like this. We cannot simplify it. So we would just leave this as its factored self, square root of 2. And that's fine. This is completely simplified down to as much as you can. And that's what you're going to have to find on some of the more difficult ones, is you're going to have to split it into separate factors and then find the perfect squares of those factors, reduce those ones down, leave the ones that you cannot find a perfect square, and then you can write it out in a simplified form like this, and you might have a few within radical signs that cannot be simplified down, and that's completely okay. But as long as you simplify all the perfect squares, you'll be good. Let's try one more, a little bit more difficult. So this one here. So let's break it into its separate parts. We'll just start out with the 9. Take each of these factors and just put them in their own radical signs. So put the 9 in one. We'll put the x to the 2nd power, and then we'll put the y to the 7th power. Do any of these simplify down? Well, this one does. We know that 3 times 3 equals 9. So this is a perfect square. We can simplify this down to 3. This one here is easy. X multiplied by x is x to the 2nd power. So it's going to just become x. And then the last one is a little bit more tricky. We'll have to separate it further. So let's just separate this out into, how about y? Take a y out and see if that does the trick. So you're left with y to the 6th power. Now will this be fine? So we already know these ones are fine. We've already done those. Does this one have a perfect square? No, it does not. You cannot times any whole, or this is not a perfect square right here. There's no whole integer. That when times by itself will become y, but this one over here can be simplified down because this is simply, I'm going to write it over here, this is simply y to the third power times y to the third power, and that would equal y to the sixth power. So the square root of this is this factor right here. So now we know we've gotten all the perfect squares and we've simplified them down. So let's just combine them. Typically you put all your numbers and variables that are out of a radical sign, you put those first, and then you put your radical sign, whichever one's left, and that's just a y. And that's how you figure out one of the more difficult ones, is you just spread them out until you can find perfect squares and reduce them all the way, and then you have your simplified answer.